So in the module 1, lecture number 2, we will study about the OSI model and the TCP IP model. So communication architecture, the strategy for connecting host computers and other communicating equipment, defines necessary elements for data communication between devices. A communication architecture therefore defines a standard for the communicating host. A programmer formats data in a manner defined by the communication architecture and passes it to the communication software. Separating communication functions adds flexibility. For example, we do not need to modify the entire host software to include more communication devices. So we do not have to modify the entire host software to include more communication devices. So why there is a need for a layer architecture? Layer architecture simplifies the network design. It is easy to debug network applications in a layered architecture network. The network management is easier due to layered architecture. Network layers follow a set of rules called protocols. The protocol defines the format of the data being exchanged and the control and timing for the handshake between the layers. So what is OSI? Full form is Open Systems Interconnection Modeler. OSI is Open Systems Interconnection Modeler. International Standard Organization ISO established a committee in 1977 to develop an architecture for computer communication. Open System Interconnection OSI reference model is the result of this effort. In 1984, the Open System Interconnection OSI reference model was approved as an international standard for communications architecture. Term open denotes the ability to connect any two systems which conform to the reference model and associated standards. So you can connect any two systems which will follow the rules of this reference model. So OSI reference model. The OSI model is now considered the primary model for intercomputer communication. The OSI model describes how information or data makes its way from application programs such as spreadsheets through a network medium such as wires to another application program located on another network. The OSI reference model divides the problem of moving information between computers over the network medium into 7 smaller and more manageable problems. So that's why we say that there are 7 layers, because it will divide the entire problem into 7 parts. This separation into smaller, more manageable functions is called as layering. So the 7 layers are there. The process is called as layering process. So OSI reference model, 7 layers. The first layer is your physical layer, which is allowing binary transmission. Then second is data link layer, access to media. Third is network layer, address and best path. Fourth is transport layer, end-to-end connections. Fifth is session layer, inter-host communication. Sixth is presentation layer, data representation. Seventh is the application layer, network processes to application. So OSI, a layered network modeler. The process of breaking up the functions or tasks of networking into layers reduces complexity. So if you break the whole thing into layers, the functions, different functions into layers, it will reduce the complexity because you will assign each layer with a different function. So the complexity will be reduced. Each layer provides a service to the layer above it in a protocol specification. So the lower layers provide services to the upper layers. Each layer communicates with the same layer's software or hardware on other computers. The lower 4 layers are transport, network, data link and physical. Layers 4, 3, 2 and 1 are concerned with the flow of data from end to end through the network, and the upper 3 layers of the OSI are application, presentation and session. Layers 7, 6 and 5 are oriented more towards the services to the application. Data is encapsulated with necessary protocol information as it moves down the layers before network transit. So your first layer is the physical layer. provides physical interface for transmission of information. So it will provide a physical interface. What do you mean by physical interface? A user interface. What is an interface? Basically, interface is something which allows two things to communicate with each other. So it will provide a physical interface. Defines rules by which bits are passed from one system to another on the physical communication medium. Covers all mechanical, electrical, functional and procedural aspects for physical communication. Such characteristics as voltage levels, timing of voltage changes, physical data rates, maximum transmission distance, physical connectors and other similar attributes are defined by the physical layer specifications. Second is your data link layer. What does the data link layer do? The data link layer attempts to provide reliable communication over the physical layer interfaces. So data link layer will allow a reliable communication to take place over the physical layer interface. Breaks the outgoing data into frames and resemble the received frames. So it breaks the outgoing data into different frames and it resembles the received frames. Create and detect frame boundaries, handle errors by implementing an acknowledgement and retransmission scheme, implement flow control, supports point-to-point as well as broadcast communication. So supports point-to-point as well as broadcast communication, supports simplex, half duplex or full duplex communication. Then your third layer is network layer. Implements routing of frames through the network, defines the most optimum path the packet should take from source to destination, defines logical addressing so that any endpoint can be defined, handles congestion in the network, facilitates interconnection between heterogeneous network, that is called as internetworking. The network layer also defines how a fragment a packet into different smaller packets to accommodate different media. Fourth is your transport layer. Purpose of this layer is to provide a reliable mechanism for exchange of data between two processes in different computers. Ensures that the data units are delivered error free. So you have to ensure, the transport layer will ensure that the data units are delivered error free. Ensures that the data units are delivered in a sequence. So they should be delivered in a sequence. If this has been received first, then this should go out first. So if you are incoming first, then your outgoing should also be the first. Ensures that there is no loss or duplication of data units. There should be no loss of data or there should be no duplicate packets. Because if there is a duplicate packet, then it will cause congestion. We don't want that congestion to take place. Provides connectionless or connection oriented services, provides for connection management, multiple connections over a single channel. Fifth is your session layer. Session layer provides mechanisms for controlling the dialogue between the two end systems. It defines how to start, control and end conversations between the applications. This layer requests for a logical connection to be established on an end user's request. Any necessary logon or password validation is also handled by this layer. Session layer is also responsible for terminating the connection. This layer provides services like dialogue discipline, which can be full duplex or half duplex. Session layer can also provide checkpointing mechanisms, such as if a failure of some sort occurs between checkpoints, all data can be retransmitted from the last checkpoint. Your sixth layer is the presentation layer. What is the function of the presentation layer? Presentation layer defines the format in which the data is to be exchanged between the two communicating entities. So the format is defined by the presentation layer. Also handles data compression and data inscription, that is cryptography. And the last layer, that is your seventh layer, is the application layer. Application layer interacts with the application programs and it is the highest level of the OSI model. Application layer contains management functions to support distributed applications. Examples of application layer are applications such as file transfer, electronic mail, remote login, etc. contains all services or protocols needed by the application software or operating system to communicate on the networks. Example, Firefox web browser uses HTTP Hypertext Transport Protocol. Email program may use POP3 Post Office Protocol version 3 to read emails and SMTP Simple Mail Transport Protocol to send the emails. OSI in action. A message begins at the top application layer and moves down the OSI layer to the bottom physical layer. As the message descends, each successive OSI model layer adds a header to it. So as the message descends means as the message goes downwards, you see TCP header is there, IP header is there, LLC header is put, MAC header is put. So what it will do, it will add a successive header to it. So successive OSI model layers add a header to it. A header is a layer specific information that basically explains what functions the layer carries out. Conversely, at the receiving end, headers are stripped from the message as it travels up to the corresponding layers. So at the receiving end, what happens? Error is stripped off. That means it is removed from the message. So this is your summary. Next we have the TCP IP model. So this is the TCP IP model. You can see in the TCP IP model we have application layer, transport layer, network and network interface. So we have what? We have these layers. That is, first is your physical layer, handling the physical media, data link layer, management of cost, effective and reliable data delivery, access to the physical networks, then network layer, handling of datagrams, routing and congestion, transport layer, management of end-to-end message transmission, error detection and error correction, application layer, use application programs using the network. So we have a difference between OSI and TCP IP, very important. OSI model 7 layers, TCP IP 4 layers, uses strict layering resulting in vertical section, uses loose layering resulting in horizontal layers. Supports both connectionless and connection oriented communication in network layer but only connection oriented communication in transport layer. Supports only connectionless communication in network layer but both connectionless and connection oriented in the transport layer. It distinguishes between service interface and protocol, does not clearly distinguish between the service interface and protocol. Protocols are better hidden and can be replaced relatively easily as the technology changes. No transparency. Protocols are not hidden and thus cannot be replaced easily. There is transparency. Replacing IP by substantially different protocol would be virtually impossible. OSI reference model was devised before corresponding protocols were devised. The protocol came first and the model was a description of the existing protocols. The first model which came was your TCP IP. Later on, there were corrections made and OSI had come up.